So, Jai Hind to all. Today I am here to present the lecture on subject signal system KEC 403, and the topic that I have chosen is classification of signals and systems. So, basically what we will see here, we will see what do you mean by a signal, what do you mean by a system, and how we will classify these signals and systems. Okay. And I am Dr. Amit Garg, Associate Professor in EC Department of AKGEC. So, let us move to second slide. So, let us start with the introduction to signal. So, what do you mean by a signal? Signal is basically a physical quantity that varies with some dependent, which carries some information, and which is varying with respect to some independent variable. Okay. And the information in the signal is basically contained in pattern of variations of some form. Okay, means what do you mean by a signal? If you want to see this, like if we will see a RC circuit, so we can see a RC circuit. Let us suppose this is our circuit. Here is resistor is there, and here one capacitor is there, and here we are calculating the voltage across the capacitor. And here we are calculating the voltage across the capacitor. So, what happened as the time goes on, then the pattern of this voltage source with respect to time, and also the voltage across this capacitor with respect to time. So, the pattern that we will obtain is basically the signal. Okay. So, you will change as the time goes on, then this voltage source will become changed. So, we will get some pattern with respect to time t, and also similarly in this case of voltage across the capacitor, again we will get some pattern. So, this is the pattern. So, this is basically our signal. So you can see that signal can be a function of time, distance, position, temperature, pressure, etc. Means here in case of signal, these all may be the independent variables, but because we are studying in signal system, and as per our curriculum, the independent variable that we will take throughout this subject is time only. Okay. So, it means we will see the variation with respect to time only. Okay. So, general example of signals that we can encounter in our daily life are basically speech signal, music signal, picture, videos, and these type of signals. So, speech is basically your one dimensional signal, music one dimensional signal, picture you can say it is an image, so it is a two dimensional signal. If we will talk about video signals, so these signals are basically three dimensional signals. Okay. But in our analysis we are restricted to only one dimensional signals. Now, come to the classification. First of all, we will see the classification of signals. So, if we will see the broad classification, then the signals are classified as continuous time and discrete time signals. Okay. So, first continuous time signals. Continuous time signals are those signals which are defined at each and every time instant of which are defined on each and every time instant. Means always there is an amplitude value with respect to time. Okay. So, we will define these type of signals as xt, where t is basically our continuous variable. Okay. So, here we can also see that the continuous time signal represented as xt is defined for a continuum of values of the independent continuous variable time. So, here time t is basically our independent variable and xt is the dependent variable. Okay. So, if we will talk about continuous time signals, then when we will discuss this continuous time signal, then xt is basically represented by a function which or a graph, like we can take some value like xt equals to t square plus 2t. So, if this is a signal, so if you will vary the value of t, then you will get the graph for xt. Okay. So, you will plot a graph. Here you will take value t values, and here is xt values. Okay. And so, you will choose the value of t. So, you will get the different values of xt. Okay. But when the signal is continuous, then this signal is defined for each and every value of Okay, so these type of signals can be defined by these functions only. Now another is your an example of continuous time signal is a speech signal basically, and discrete time signal represented by xn where n is an integer. Here in this case t is not need to be an integer but maybe an integer, but here it is it must be it is essential that this n should be an integer value, means discrete time signals are only defined at discrete time instants. Okay, so if you will draw a discrete time signal, then the independent variable that we will take it as n, and here is basically xn. And what happened, the value of this signal is defined only at discrete time instants like this. So these are discrete time instants, let us say 0, 1, 2, 3. So these are the amplitude values that you are getting. Basically these are the amplitude values that you are getting at discrete time instants, represents a discrete time signal. One important thing is that the value in between these discrete time instants is not actually 0, but it is not defined. This value is not defined, means we only know the values on these time instants, but the value between these time instants is basically undefined. Okay, so there are so many ways by which we can represent a discrete time signal, like our continuous time signal can only be represented by some this type of function, but discrete time signal can be represented by so many manners, like graphical manner, functional, tabular, sequence representation. So these are the various representation by which we can represent our discrete time signal. The most popular is the sequence representation. Sequence representation means, let us suppose I am writing a signal xn and the value of xn is, let us say 1, 3, 5, 7, 9 like this, and if I am putting arrow here, it means this is the value that is corresponding to n equals to 0, and this is for n equals to 1, this is for n equals to 2, and this is for n equals to 3, and this value is corresponding to n equals to minus 1. Okay, so this arrow defines the position for n equals to 0. If there is no arrow in this sequence, then we will assume that the first element is corresponding to value n equals to 0. And the example for the discrete time signal is stock market index is an example of a discrete time signal, weekly stock market index. Otherwise, if you will see on daily basis, that this may be a continuous type of system. Now we will see continuous and discrete amplitude signal. So we can see this slide by which we can see the different type of signals, like first type of signals are continuous time, continuous amplitude signals. Continuous time means you can see that time is continuous, means this signal is defined at each and every time instant, and also you can see the amplitude value. If you will see from here to here, maybe let us say this value is 0 and this is let us say 5. So between 0 and 5 you are having infinite number of values that can be represented by the magnitude, so that if the values are infinite, so that we can say the amplitude is also continuous here. Okay, so this continuous time, continuous amplitude signals are also called as analog signals. Okay, now come to the second type of signal, that is discrete time continuous amplitude signal. Means now this signal is defined only at some discrete time instants, let us say 0, this is the time interval. So you can see these signals are defined at discrete time instants only, but the amplitude value is between this to this, again 0 to 5 let us say. So these values may be infinite values, and these values can be infinite values. So when infinite values of magnitude exist, then we will call this type of signal as discrete time continuous amplitude signal, because this is discrete in time but continuous in amplitude. Continuous amplitude means we are having infinite number of values of amplitude at discrete time instants. Okay, Third type of signal is continuous time discrete amplitude signal. So you can see that this signal is continuous in time. You can see for each and every time instant we are having the magnitude value. So you can say this signal is continuous in time, but if we will see the amplitude, then you can see that this. So you are having some finite number of values of amplitude. Okay. So you are having some finite number of amplitude values, that values may be anything, but you can count these values. So if you can count these values, so these are finite values, that's why this signal is continuous in time but discrete in amplitude, because we can count these values. Okay. Now last type of signal is basically discrete time discrete amplitude signal. So you can see this signal is defined only at discrete time instants. And if we will see the amplitude, then for each and every sample value we are having finite values, means you can count the amplitude, values. Okay. So if you will count the amplitude values, you will find that these are finite values. Okay. So this type of signal is nothing but your digital signal. Okay. Means so this is your analog signal, this is your digital signal, and this is discrete time continuous amplitude, and this is discrete time discrete amplitude signal. Okay. So difference between this and this is only that here are the values, infinite values of magnitude or amplitude are there, which cannot be countable, but here we can count. Okay. Now come to the classifications of signals. Okay. So we will take both the signals at the same time, like continuous time signal and discrete time signal. Okay. So because the classification is same for both type of signals. Okay. So first type of classification that can be done is that deterministic and non-deterministic signals. So deterministic signals are those signals which are defined over time, Okay. Or you can say the value of these signals can be specified in time, or we can calculate the value of the signal at any time instant, you can say. Okay. So you can say these type of signals are specified in time, like example is your unit step signal, ramp signal, etc. So this is your deterministic signals. And non-deterministic signals are basically also called random signals. So these type of signals are not specified completely in time. You can, but although analysis can be done. So what type of analysis we will prefer over here? So here the analysis that we will prefer is stochastic analysis. So in this analysis, what happen? We can determine the value of this signal at a particular time, not exactly, but with some probability. So we will, means you can say that the value of a particular signal at this time is, let's say, x. So that x is some probabilistic value. Okay. So you can say these type of signals are probabilistic in nature and can only be analyzed stochastically. Okay. So this is deterministic and non-deterministic signals. Then periodic and aperiodic signals. So periodic signals are those signals which repeat itself after a certain interval of time, that is called as time period. So if xt plus t is equals to xt for all t, and similarly in discrete time signal this is xn plus n naught equals to xn for all n. So you can say the signal is periodic, and if the signal is not periodic, means it is not following these conditions, then in that case signal is basically aperiodic signal. Okay. And the smallest value of this period t or n naught is known as fundamental period. Okay. So what we have to calculate, basically generally we have to find out, we have given some function and we have to find out that whether the given signal is periodic or aperiodic, and once you will find that it is periodic or aperiodic, and if it is periodic, then the next question is what is the fundamental period for this particular signal. Okay. Now even and odd signals. So even signals are, you can say, simply signals if x of t will be equal to x of minus t for all t, then signal is even signal. Okay. Okay, and if of xt will be equal to minus of x of minus t for all t, then this is an odd signal. So you can see these type of signals are basically symmetric about vertical axis, symmetric about vertical axis. Okay, and these type of signals are anti-symmetric about vertical axis. Okay, you can write it like x of minus t will be equal to xt and x of minus t will be equal to minus xt also. Okay, so this is for a continuous time signal I have shown. Otherwise you can also write it for discrete time signals. Okay, another important thing is that we can also find out, we have given a question like find out the even and odd component of a signal, so that we will see later on. Then the fourth type of classification is causal, anti-causal and non-causal signals. So causal signals are those signals which are defined when input is given. Means you can say causal signals are those signals for which, like you can see by an example, let us say this is a unit step signal. Okay, this is a unit step signal. So at t equals to 0, you are getting some value, and t equals to 0 and greater than t equals to greater than equal to 0. This signal is defined only at t greater than equal to 0. So this signal is basically your causal signal. Okay, so the signals that are defined only when the value of time is equal to 0 or greater than 0. Okay, so these are causal signals. Anti-causal signals are those signals which are defined, let us say this is anti-causal signal u of minus t. So these signals are defined only for values of t which is less than 0 or equal to 0. Let us say we can take this equal condition in both the cases, or also we cannot take it. Okay, because at t equals to 0, this unit step signal is undefined basically. Okay, so this is your causal signal and this is your anti-causal signal. And what about non-causal signal? Non-causal signals are those signals which is neither, you can say, causal or neither anti-causal. So what type of signals are those signals? Like you can take this signal. Okay, so this is the origin, and this signal you can see is defined for t less than 0 and also for t greater than 0. Okay, so these type of signals are defined when the value of t is less than 0 as well as for t greater than 0. So these are basically non-causal signals. Okay, so causal, anti-causal and non-causal. Okay, next is energy and power signals. So energy signals are those signals which are having finite amount of energy and their average power is 0. And the power signal are defined as the signals which is having infinite amount of energy but finite average power. Okay, so these are the expressions for energy and power for continuous and discrete time signals. Okay, so for calculating energy for continuous time signal, we will use this expression where xt is our signal and this is mod of xt square dt, and similarly for discrete time signal the expression is this. And for power we can see the expressions are these. Okay, so this is for continuous time signal. So there are two types of there are two ways by which you can write these expressions. Like one is this, here you can see 1 upon t is there, here 1 upon 2t is there, but limit is minus t by 2 here, and here is minus t to t. So you can use any of these expression for calculating the power of continuous time signal. And similarly for discrete time signal we can calculate the power using these expressions. Okay, so if we have to determine whether a given signal is energy signal or power signal, so what we will do, we will calculate the energy and power of the signal. If the energy is finite and power is average power is 0, then signal is energy signal. And if we will see that power is finite but energy is infinite, then in that case signal is our power signal. But let us suppose you will calculate the things and you are getting that E equals to infinity and also power equals to infinity, then in that case this is neither energy nor power signal, neither energy nor power signal. Okay. Now introduction to system. So a system is defined. So we have already seen the what do you mean by a signal and how we will classify the signals. Now we will see about the system. So introduction to system. So a system is defined as an entity that acts on an input signal and transform it into an output signal. So you can simply say system is like this. This is your system. Okay. And we are applying any input it to, let's say xt is the input. So we are getting the output yt. Or for discrete time signal also xn or yn. Okay. So system, what is system? A system is defined as an entity that acts on an input signal and transform it into an output signal. So what happened? When you will take when you will provide an input to this system, the system will give you output that will be represented by yt in case of continuous time signal, and for discrete time signal it is defined as yn. Okay. So now this system can be represented by its impulse response, which is defined as ht, or transfer function which is defined as, let's say, hs. So you can say the response or output of the system means yt depends upon the transfer function of the system. You can say transfer function or also impulse response. Okay. And systems are again broadly classified as continuous time systems and discrete time systems, like in the case of continuous and discrete time signals. So now we will see continuous and discrete time systems. So a continuous time system, basically this is a continuous time system. So this continuous time signal only the continuous time signal only process the continuous time input. Okay. So you can see xt is continuous time input and you are getting the continuous time output signal when you are using or when you are passing this through a continuous time system. And similarly for discrete time system, xn is the input and yn is the output. And how we will write this expression? So xt times yt is basically your continuous time signal, continuous time system, because input is continuous and also output is continuous. And similarly a discrete time system can be represented by this notation, xn tends to yn. Okay. Okay. So it means you are applying a continuous time input here and you are getting continuous output from here, and here you are applying discrete time input and you are getting discrete time output here. Now come to the first type of system, linear and non-linear systems. So basically linear systems are those systems which follows the principle of superposition, and superposition simply implies that the response resulting from several input signals can be computed as the sum of the responses resulting from each input signal acting alone. So you can take it like this is our system. What we are doing, one time what we are doing, we are giving so many inputs to this system and we are calculating the output, we are getting different output and we are combining these outputs. Okay. And another time we will sum these inputs and we will give as input to here, and the output that we are getting here is basically the combination of these outputs. Okay. So how can we define the linear systems then? So if we will take this type of signal x1t plus x2t, then response of this input is if y1t plus y2t. So this is one property. Another property is that the response to ax1t is ay1t, where a is an arbitrary constant. This is the second condition. So you can see this is the first property and this is the second property. If the system follows these two properties, both the properties, then the system is linear one. Okay. First property is referred as additivity property, you can see here, and the second property is called as scaling or homogeneity property. Okay. So if additivity and homogeneity property both are shown by a system, then that system is the linear system, otherwise it is non-linear. Okay. So it means continuous time system. In a single statement we can call it like this: ax1t, if ax1t plus bx2t we will get pass through the system and we will get ay1t plus by2t, and for discrete time signal, discrete time system, ax1n plus bx2n apply, and we are getting ay1n plus by2n. If it is so, then system is linear, otherwise it is non-linear system. Second is time varying and time invariant system. So time varying, time invariant systems are those systems which does not change its behavior with respect to time. So if the time changes and if the signal is not, if the system is not changing its behavior, then you can say system is basically time invariant, otherwise it is time variant. Okay. Or you can say a system is said to be time invariant if a time shift in the input signal causes an identical time shift in the output signal. Okay. So it means, let us suppose you are having a signal xt for which you are getting the output yt, and you are delaying this input by an amount t naught. So your output should also be, if your output will also be delayed by this t naught unit, then you can say system is time invariant. Otherwise system is time variant. Okay. So this is the case for continuous time signal and this is for the discrete time signals. Okay. So this is second type of classification of system. Third type of classification of system is causal and non-causal system. A system is causal or non-anticipatory. Okay, it is also called non-anticipatory. A system is causal if the output at any time t naught or n naught depends only on the values of the input at the present time and in the past time. Means you can say if the output of the system depends upon, if the present output of the system depends upon present input values and past input values only and not depends upon future values, then you can say your system is causal system. Okay. And a system which is not causal, it will be your non-causal system, or you can say non-causal system, the present output depends upon the present output depends upon the future value of the input. So and one statement is that all memoryless systems are causal systems since the output responds only to the current value of the input, but not all causal systems are memoryless, as for storing past values memory is required. Okay. Now come to stable and unstable system. So a stable system is one in which input leads to responses that do not diverge. Means if you are applying a finite amount of input to the system and you are also getting the output which is finite, then you can say the system is stable system, and if it is not so, then system is unstable. So you can represent it like this type of function. For mod of xt is less than equal to bx, where bx is some finite quantity and it should be less than infinity for all t. So if you are taking a bounded input like this and you are getting the bounded output like this, then the system is stable, otherwise it is unstable system. Then system with and without memory. Systems without memory are also called static system or memoryless system. So when there is no memory, you cannot store any past or future value of the input. Okay. So you can say here you will apply the input and you will get the output, but you cannot save any present or past, any past or future values. And in system with memory, you can say you are having memory, so you can store past values and as well as future values of the system. Example for memoryless system is, let's say you are having a resistive network. Okay. So in resistive network, you are not having any memory, so you can only take, you will only apply input and you will get the output. And system with memory, you can say in this case, if you will take a, you can take a RC network. So in case voltage across capacitor will act as the past value of the input. Okay. So in that case, memory is required to store it. So that type of system is basically the dynamic system. And last one is the invertibility and inverse system. So a system is invertible if by observing the output we can determine its input, that is, we can construct an inverse system that when cascaded with the given system yields an output equal to the original input of the given system. So you can see this is the system xt I am applying over here, I am getting the output yt, and if I am having a system in which is the inverse of this system, then the output of this inverse system is, let's say, zt, that should be equal to xt, means we will again get the same input. So a system is said to be invertible if its inverse system exists. Okay. So, and if its inverse system does not exist, then we will say that that system is non-invertible system. So, invertible systems are systems for which inverse systems exist. So, this is the case. So, in which case invertibility system will be invertible? When we are applying such type of input, you can say when the mapping between xt and yt is 1 to 1 mapping only, then in that case this inverse system exists. If mapping is many to one, then in that case it is not possible to get the inverse system. Okay. So this is basically we have seen the classification of systems also. So thank you very much for your kind patience. Thank you so much.